So this is the first demonstration we have here. It's the Dataman 475 with Torchlight. Now the scenario that we're demonstrating here is something similar to order fulfillment. Now typically what you might see is an operator having to pick up a handheld reader and scan a code and then move on to the next item. What we have is a fixed mount barcode reader. So the operator doesn't need to pick up that handheld reader. All they need to do is to move the object in front of the reader and it's automatically scanning. The Dataman 475 has some very useful and unique features which make it perfect for this application. Firstly, it's got a laser aimer so you can see exactly where to put the code in the field of view. And then it has a green operator feedback light to let the user know that they can now move on to the next target. So the box that I've got here is designed to simulate the various different scenarios that you're going to see in the order fulfillment application. So your barcode might have some damage, your barcode might have some plastic over it, more damage, or the kind of worst case scenario is where you're going to have an object obscuring the field of view and some plastic all at the same time. So this is our box gap demonstration here, designed to show off our patented HDR Plus technology. The scenario that we're mimicking here is a conveyor belt scenario where you have boxes which are very, very close together, but you still want to maintain that level of traceability by reading codes down between those gaps. Now, with throughput being an ever-present concern for customers, they really only have three options. One is to increase the speed, two is to decrease the gap, or three is to build a new facility. And so here we're really addressing the first two of those concerns. Our Dataman reader is positioned at a very, very steep angle looking at these two boxes. Now the boxes are 600 millimeters high and there's a very narrow 100 millimeter gap between the two boxes. Now as we're cycling through our three types of image capture mode, so no HDR, HDR and then HDR plus, we're able to get further and further down that gap to be able to read the barcodes. You can see when we don't have HDR on, we're only able to capture this barcode on the top. When we turn on HDR, we're able to capture the barcode down here in the middle. And then finally, when we turn on HDR plus, which is Cognex's patented technology, we're able to get all the way down to the bottom 600 millimeters down in that 100 millimeter gap. So the way in which HDR Plus is different from standard HDR is instead of working on the whole image as a one, it works on a small part of the image and then moves across so that you get a much more balanced image and therefore much better read rates as a result. This application shows our Torchlight with built-in time-of-flight sensor when used in combination with our high-speed liquid lens. For years, vision applications have been limited by the depth of field they've been able to achieve with their optics. Here, we're able to detect and refocus between shots, effectively eliminating this problem, while maintaining the speeds of the application, but with no mechanically moving parts. As you can see here, the reader is able to detect and refocus, read our code all the way up and down this linear stage. As well as this, we're able to use the time of flight sensor to effectively change the settings on the reader depending on where it detects the item in front of the camera. This is useful in logistics because we're seeing a larger amount of individual items being distributed through the supply chains, and that's leading to a much wider variety of packaging scenarios that we've got to deal with. Facilities are increasingly looking for solutions that don't require operators to manually adjust parcels when they're inducting them so that the barcodes are facing up. By adding a bottom side reader to your existing solution, you can effectively eliminate this need. What we have here is the new Dataman bottom side scanning solution. So for years, the industry has used line scan technology for just this application. We've used line scan technology for this application. But what we've done here is implement new technology to change the way in which these images are being formed before passed over to the decoder. Instead of taking a single line of pixels and building it up, what we're doing is taking an image of the whole gap and then stitching those larger images together. Now the benefit that we have here is that we don't just use the encoder pulses to stitch those images together. Cognex, as a vision company, is able to use feature recognition between those individual images to be able to stitch them together much more accurately. Now the result that you have here is a much more robust solution when compared to your traditional line scan technology. So when we look at this as a solution, you have three main benefits. Firstly, the robust reading, which in logistics scenarios means that you're going to be able to deal with things like boxes, skipping over gaps, or accelerating and decelerating. This unit comes pre-assembled, pre-wired and pre-focused, so all you need to do is slide it under the gap, and the software will guide you through setting it up, and it will work in master-slave groups with your normal Dataman readers. So the third advantage here is the maintainability. Not only do you have a perspex cover and a mirror which can be removed with a single locking pin, but you've also got a built-in air knife to remove debris from the surface there. Cognex dimensioning solutions use patented 3D and 2D snapshot technology to provide accurate inspections of regular, irregular and complex items, both statically and in motion. This technology enables Cognex to provide simplified solutions to traditionally difficult 3D tasks, removing the need for complex device calibration or the need to impose typical integration limitations. This inspection was set up using the intuitive onboard setup wizard that guides users quickly all the way from mounting the device to outputting inline results so that the customer can get fast and effective data to guide their processes, whether that be dimensional or shape data for item sortation and load optimization, exactly like we've got here, or to provide other types of inspection data, either to enable other forms of logistics automation or to prevent QA issues from leaving the facility. This standalone solution is a flexible and mobile dimensioning, weighing, scanning system for small to medium-sized packages. The combination of Cognex's 3D and image-based barcode reading technology, coupled with scaled data, enables size, shape, weight and barcode information to be quickly and accurately captured and transmitted for traceability, shipping cost estimation and load optimization tasks. When compared to traditional methods of manually capturing the data, this solution provides significant ergonomic benefits to the user, resulting in increased throughput for faster facility return on investment. All the user needs to do is place the item on the bed here, and they're automatically getting dimension data, scale data, and ID reading data. And you're good to go. The Cognex item detection system is a one-for-all sorter solution that's easily integrated without expert knowledge. It provides customers the ability to improve their sortation processes by delivering best-in-class object detection rates whilst maintaining lowest false environmental failures using both 3D and 2D inspection data. What we've got here is the 3DA1000 positioned over a simulated tray sorter. Now, this will work on any type of sorter, be it crossbelt, Bombay, or any other type of sorter. Typically, you would have the 3DA1000 stationary and then have the sorter moving underneath. What we're doing here is not only detecting items, but also giving more information. Here you can see we can detect multiple items sitting on one half or the other of a tray, items which have been slightly misaligned and are overhanging, or in fact near the edge of the tray and are likely to fall off on the next corner. Now this solution It's setting itself apart from the traditional solution in this kind of space, where you would typically see something which would either require a specific type of tray, or for you to drill holes in your tray to retrofit the solution, or to apply some form of sticker or surface to the tray itself, which requires additional maintenance. This is easy to install, easy to retrofit, and again, it's carrier agnostic. This demonstration shows one of the new features of the 3D-A1000, side-by-side detection. Here we can accurately segment and identify items that should be singulated in their production flow. This helps customers to correctly track and trace incoming or outgoing products through their processes, preventing costly rework and downtime due to stoppages and the loss of goods or incorrect shipments from leaving the facility. So this is our final demonstration, a full 6-sided tunnel. This is where all of the technology that we've been talking about today comes together in one particular solution. You've got the Dataman ID reading, best in class. You've got the 3D-A1000 dimensioning system and the bottom side solution, all working together to give a complete solution. Not only is it incredibly technically advanced using the individual components, but it's also got a very slim form factor compared to other tunnels that you'll see on the market today, allowing you to have that full traceability in your production facility. But this tunnel's got one more trick up its sleeve. This is actually the first ever 3D calibrated tunnel in Europe. By passing one of these calibration boxes through the tunnel, we've been able to effectively teach each of the readers where they are in 3D space. Now what that means to a customer is that they can run boxes incredibly close together, and the readers will be able to distinguish which box is which in a single frame, in a single field of view, and assign all of the barcodes that it sees onto the correct box. What you'll notice here is we have two boxes very, very close together, and in a single shot it will be able to read both boxes and pass us the codes assigned to the correct boxes alongside all of the dimension data that we would traditionally expect from a 3D tunnel.